The universe is vast beyond imagination, mysterious beyond comprehension, and endlessly fascinating. From the tiniest subatomic particles to colossal galaxies stretching across billions of light years, the universe is a living puzzle that humanity has been trying to solve for thousands of years. Despite incredible advances in science and technology, much of the cosmos remains unknown. These unanswered questions form what we call the universe of the mysteries, a realm where science meets wonder, curiosity meets uncertainty, and knowledge meets the infinite. In this deep dive video, we explore the most profound cosmic mysteries, why they matter, and how they shape our understanding of existence itself. The universe, bigger than we can imagine. The observable universe is estimated to be about 93 billion light-years in diameter, yet this may represent only a small fraction of what truly exists. Beyond what we can see lies a vast unknown, possibly infinite in size. Scientists believe the universe began with the Big Bang, a powerful expansion that occurred around 13.8 billion years ago. However, what caused the Big Bang and what existed before it remains one of the greatest mysteries of all time. The universe is not static. It is constantly expanding, and surprisingly, that expansion is accelerating. This unexpected behavior challenges our fundamental understanding of physics and reality itself. Dark matter, the invisible architect of the cosmos. One of the most puzzling discoveries in modern astronomy is dark matter. Although it cannot be seen, touched, or directly detected, scientists believe dark matter makes up about 27% of the universe. Its presence is inferred through its gravitational effects on galaxies and galaxy clusters. Without dark matter, galaxies would not have enough mass to hold themselves together. Stars would drift apart, and the cosmic structures we observe today would not exist. Yet, despite decades of research, no one knows what dark matter is made of. Is it composed of undiscovered particles, or does it point to a flaw in our understanding of gravity? This mystery alone suggests that much of the universe operates under laws we have yet to fully understand. Dark energy, the force driving cosmic expansion. Even more mysterious than dark matter is dark energy, which accounts for nearly 68% of the universe. Dark energy is believed to be responsible for the accelerating expansion of the universe, acting as a kind of anti-gravity force. Unlike gravity, which pulls matter together, dark energy pushes space apart. Its origin, nature, and ultimate fate remain unknown. Some theories suggest it is a property of space itself, while others propose entirely new physics. If dark energy continues to dominate, the universe may eventually experience a big freeze, where galaxies drift so far apart that stars burn out, leaving behind a cold, dark cosmos. Black holes, cosmic monsters, or gateways. Black holes are among the most dramatic and mysterious objects in the universe. Formed when massive stars collapse under their own gravity, black holes possess gravitational pulls so strong that not even light can escape. At the center of every large galaxy, including our Milky Way, lies a supermassive black hole. Yet, what happens inside a black hole remains unknown. The laws of physics as we know them break down at the singularity, a point of infinite density. Some theories suggest black holes may connect to other universes or distant regions of space through wormholes. While this remains speculative, it highlights how black holes challenge our understanding of time, space, and reality. Are we alone in the universe? The question of extraterrestrial life is one of humanity's oldest and most profound mysteries. With billions of galaxies, each containing billions of stars and potentially habitable planets, the odds of life existing elsewhere seem high. Astronomers have already discovered thousands of exoplanets, many located in the habitable zone where liquid water could exist. Mars, Europa, and Enceladus are also being studied for signs of microbial life. Yet, despite these promising discoveries, we have found no confirmed evidence of intelligent extraterrestrial civilizations. This contradiction is known as the Fermi paradox. If intelligent life is common, why haven't we detected it? Time, space, and the nature of reality. Time itself is one of the deepest cosmic mysteries. According to Einstein's theory of relativity, time is not absolute. It can slow down or speed up depending on gravity and motion. Near black holes, time may nearly stop, while at the quantum level, time behaves in strange and unpredictable ways. Some physicists suggest that time may not even be fundamental, but rather an illusion created by human perception. Others propose the existence of multiple timelines or parallel universes, collectively known as the multiverse. If the multiverse exists, our universe may be just one bubble in an endless cosmic ocean. The cosmic microwave background, echo of creation. The cosmic microwave background, CMB, is faint radiation left over from the early universe, often described as the afterglow of the Big Bang. By studying the CMB, scientists gain insight into the universe's infancy and its initial conditions. Tiny temperature fluctuations in the CMB reveal how galaxies eventually formed. However, anomalies within this radiation suggest that our universe may have been influenced by forces or events beyond our current understanding. The CMB serves as a cosmic fingerprint, holding secrets about the universe's origin and evolution. Quantum physics and the cosmic connection. At the smallest scales, the universe behaves in ways that defy common sense. Quantum mechanics reveals that particles can exist in multiple states simultaneously and influence each other instantly across vast distances, a phenomenon known as quantum entanglement. Reconciling quantum mechanics with general relativity remains one of the biggest challenges in physics. A unified theory, often called the theory of everything, could explain all forces and particles in the universe. Until then, the relationship between the quantum world and the cosmic scale remains one of science's greatest mysteries. The fate of the universe. How will the universe end? Scientists propose several possible scenarios. The Big Freeze suggests the universe will slowly cool as stars burn out. The Big Crunch theorizes that expansion could reverse, collapsing the universe back into a singularity. Another idea, the Big Rip, predicts that dark energy could eventually tear apart galaxies, stars, and even atoms. Each scenario depends on the true nature of dark energy and the universe's overall density, both of which remain uncertain. Why the universe of the mysteries matters. Exploring cosmic mysteries is not just about satisfying curiosity. It helps us understand our place in the universe and the fundamental laws that govern existence. Every discovery reshapes our worldview and opens new possibilities for technology, philosophy, and the future of humanity. The universe teaches humility. Despite our progress, we are still beginners in a cosmic classroom, learning one lesson at a time. An endless journey of discovery. The universe of the mysteries is a reminder that knowledge is never complete. Every answer leads to new questions, and every discovery reveals deeper layers of the unknown. From dark matter and black holes to time, life, and reality itself, the universe continues to challenge and inspire us. As science advances, we move closer to understanding these mysteries, but the beauty of the cosmos lies in the fact that it will always hold secrets. And perhaps that endless mystery is what makes the universe truly extraordinary.